We have a second event for International Day of Mathematics. And again, it's organized by, well, not again organized, but it's organized by Christiane Rousseau, who was a main actor of the previous event. And she will introduce our speaker today.
Alors, bienvenue à cette grande conférence publique du Centre de recherche mathématique qui se tient dans le cadre de la Journée internationale des mathématiques. En fait, on est deux organisateurs. Je travaille avec Henri Darmon, mais il est allé se promener de l'autre côté de l'Atlantique et il est en quarantaine dans un hôtel à Zurich avec la COVID. Francis Su received his PhD from Harvard in 1995. He was a student, in fact, with Henri Darmon, for those of you who know him. He then took a position at Harvey Mudd College, where he is Benedictson Kawa Professor in Mathematics since 2012. He has done a lot of service to the mathematical community. He has been president of the Mathematical Association of America, and he is now vice president of the American Mathematical Society. His research interests are in geometric and topological combinatorics, with application to mathematics economy, game theory, voting theory, and mathematics of fair decision. In particular, several of his papers treat of the problem of fair divisions, or how to share goods or cores so that everyone is satisfied of their share. He received many prizes for teaching and education, including the 2018 Halmos-Ford Award for Mathematics Writing and the 2013 Hamo Award for Distinguished Teaching at College Mathematics. His book, Mathematics for Human Flourishing, published by Yale University, won the 2021 Euler Book Prize. When we started brainstorming who could be the best person to lecture around the 2022 theme for International Day of Mathematics, so the theme is Mathematics Unites, Francis Su was the most natural choice. So we are pleased to have him among us tonight, lecturing on mathematics for human flourishing. Francis, the floor is yours.
Great. Well, merci. Thank you very much. I appreciate this opportunity to be with you, even if it's half or a continent, the other side of the continent. Welcome. Happy International Day of Mathematics. The theme, as you know, this year is Mathematics Unites. And, you know, one of the questions you might ask is, in what way does mathematics unite us? Let me start with a piece of art as a way of wrapping our heads around this question. This is a painting by George Frederick Watts in 1886, and it's entitled Hope. Take a moment to look at it as a work of art. What do you notice about the painting? And what do you wonder? Perhaps the beauty of the painting draws you in, right? You might grasp the relationship of the elements of the painting and ask what's going on. Why is this woman blindfolded? What is she doing? It looks like she's plucking an instrument. And if you look closely, it's actually a lyre with a single unbroken string. She looks like she's in despair. She looks like she's straining to hear the music of the lyre. And maybe only after some time do you notice that out of her view, just over her shoulder, there is a single lone star shining just out of her view. And you wonder, why is she in despair? Why can't she see this star? What does a star represent? And why is the painting entitled Hope? And then you seek to find out more context, right? You learned that in the 1880s, the world was emerging from a recession known as the Long Depression. This was the biggest before the Great Depression. You might see then that the painting captures the pessimism of the times. In 1959, Martin Luther King wrote a sermon entitled Shattered Dreams, based on this painting, in which he asks, who has not had to face the agony of blasted hopes and shattered dreams? All right, so why do I open with this art? Well, it's because we see it. When we see art, we seek to engage it because we all have basic human desires, right? It's beautiful and we desire beauty. It's relevant to our current moment and we desire meaning, right? It's captivating. We desire to explore it. It causes us to wonder, to ask questions, to seek its truth, to be willing to be patient in waiting for a star to show itself. And why don't we approach math the same way that we approach art? Right? Many people talk about math as though it's some kind of universal language, but that only superficially, I think, describes how mathematics unites human beings. You see, math is more than just a way to describe the world. It's more than just a set of skills like doing an arithmetic or factoring a quadratic. Mathematics is deeply human. And this deep connection between mathematics and human desires shows why people in every culture around the globe do mathematics, not just to build things or to conduct commerce, but for enjoyment and exploration. And I'd like us to think a little bit then today about what is it that makes mathematics deeply human? What is the purpose of mathematics? And whom do we believe has potential to do mathematics? You see, every being cries out silently to be read differently. That's a quote of Simone Weil. Several years ago now, I received this letter out of the blue from an inmate in a federal prison. His name is Christopher Jackson. He has been in prison since he was a teenager. He was involved in drugs in high school. He never finished high school. He was involved in a series of armed robberies, and that landed him in prison with a 32-year sentence and no chance of parole. So he's going to be out when he's 50 years old. And he wrote me this letter. When you think about who does mathematics, would you think of Christopher? But here's what he said. He said, I've always had a proclivity for mathematics, but being in a very early stage of youth and also living in some adverse circumstances, I never came to understand the true meaning and benefit of pursuing an education. Those are Chris's words. And he went on to tell me how he had worked his way through a series of textbooks studying algebra up through, at that time, calculus 1 and calculus 2. And he was now writing me for help in furthering his mathematics education. And so when you think of who does mathematics, would you think of Christopher? I certainly wouldn't have. And now, of course, many years later, several years of correspondence, Christopher has inspired me, a professional mathematician, to believe even more fully that math actually has something to offer everyone. Because every being cries out silently to be read differently. As I mentioned, those are words of Simone Weil, who is a well-known French religious mystic, a widely revered philosopher. But you may not know that she is the younger sister also of André Weil, one of history's most famous number theorists. And for Simone Weil, to read someone means to interpret or make a judgment about them. You see, she's saying every being cries out silently to be judged differently. And I have often wondered if she were talking about herself, because she too loved and participated in mathematics, but she was always comparing herself to her older brother. She says this, quote, at 14, I fell into one of those fits of bottomless despair that come with adolescence, and I seriously thought of dying because of the mediocrity of my natural faculties. The exceptional gifts of my brother, who had a childhood and youth comparable to those of Pascal, brought my own inferiority home to me. I didn't mind having no visible successes, but what did grieve me was the idea of being excluded from that transcendent kingdom to which only the truly great have access and wherein truth abides. And I preferred to die rather than live without that truth. You see here, she was even contemplating suicide because she felt so small, so minuscule in her natural abilities in mathematics. And yet we know Simone loved mathematics because she used mathematical examples throughout her philosophical writing. You'll in fact find her in photos like these of Bourbaki. This is a group of influential French mathematicians that included her brother. You'll see she's the lone woman sitting among a bunch of men. This is her on the left, poring over some notes. And this is Andre, her brother, waving the bell. And I often wonder what her relationship to mathematics would be like if she weren't always in Andre's shadow. You see, every being cries out silently to be read differently. Now, of course, many people look at me, a math professor, and think that my relationship to math has always been solid. And maybe you think I've never struggled in math. But I grew up in a small town in South Texas with limited opportunities. Most of my high school peers did not go to college. I did have supportive teachers who encouraged me in high school and at university. I managed to get admitted to Harvard for my PhD, but I felt out of place there since I didn't, like many of my colleagues, come from an Ivy League school, and I didn't have a full slate of graduate courses before I entered. So I felt like Simone Weil, standing next to future Andres, thinking I would never be able to flourish in mathematics if I were not like them. I was even told by one professor that I didn't have what it takes to be a successful mathematician. That's an unkind remark, isn't it? And it forced me to consider, among other things, why I was even interested in doing mathematics. And that's a question I think all of us should ask. Why do mathematics? Why should anybody learn mathematics? Why is Christopher sitting in a prison cell studying calculus, even though he wouldn't be using it as a free man, at least for another 20 more years? Why was Simone so captivated by transcendent mathematical truths? And why should anybody persist in doing math when others are telling her in subtle and maybe not so subtle ways that she doesn't belong? And of course, society is also asking about its relationship to mathematics these days, isn't it? Is math only a tool to make you, quote, college and career ready so that you can go and achieve your real aims in life? Or is mathematics unnecessary for most of us and only needed for the elite few? Or this question, which some of us have asked and maybe more of us have heard asked: why study math if you'll never use what you're learning? When am I ever going to use this? Right? The common answer to that question often from teachers is because you're going to need to know it later, right? But that answer is often unsatisfying, and often it's untrue, right? Are they really going to need to know calculus later? Not everybody. And yet, is there some purpose then for learning mathematics beyond just its usefulness? You see, these questions arise because math is often just seen as a means to an end, a tool you'll use later rather than a pursuit that serves you well right now. And so when kids ask, when am I ever going to use this? What they're really asking is, when am I ever going to value this? And they're equating value with utility because they haven't seen that they can value anything more. And yet in a Florida prison, Christopher has never asked, when will I ever use this, has he? He's poring over textbooks, learning math in hopeful anticipation of its own intrinsic rewards. And so if you asked me, why do mathematics? I would say this: because mathematics helps people flourish, right? Mathematics is for human flourishing. It's in this sense that mathematics can be a force that unites people. Mathematics helps people flourish. When I say human flourishing, I'm referring to a certain wholeness of both being and doing, of realizing one's potential and helping others to do the same, of acting with honor and treating others with dignity, of living with integrity, even in challenging circumstances. And so It's not just the same as happiness, and it's not just a state of mind. One way that people speak of human flourishing is the well-lived life, right? What does it mean to live life well? That's a question that philosophers have asked throughout the ages. The ancient Greeks had a word for human flourishing, eudaimonia, which they view as a certain overarching good in life. There's a similar word in Hebrew, shalom, which is used as a greeting. Shalom is often translated peace, but the word has a far richer context, right? To say shalom to someone is to wish that they would flourish and live well. And Arabic has a related word, salam. And a basic question then taken up by human beings throughout the ages is, how do you achieve human flourishing? What is the well-lived life? Aristotle would say that flourishing comes about through the exercise of virtue, right? And you can think of virtue as a certain excellence of character that leads to excellence of conduct. Now, most people, when you say virtue, they think of moral virtues, right? Like truthfulness or goodness or decency or something like that. I guess I want to enlarge our picture of what virtue could mean. For instance, virtue could include persistence in problem solving. Virtue could include creativity and curiosity. And so what I'd like us to think about is that doing mathematics well, cultivates in us virtues, right? The practice of mathematics cultivates virtues that helps people flourish. And these virtues serve you well no matter what profession you go into or wherever your life takes you, right? And so when people think about what mathematics is good for, they're often thinking about skills, but excuse me. Skills are, things like factoring quadratic, right? Virtues are things like creativity and problem solving. Which one of those is going to be more useful to you in your life? I claim it's the virtues, if you want to talk about usefulness. But I don't even want to talk about usefulness. I want to talk about how it is that mathematics helps people flourish. And the movement towards virtues happens through basic human desires. Basic human desires are things that all of us long for, the things that actually make us human, right? A desire for beauty or for truth. And so what I'll do this evening then is to talk about several of these basic human desires and how it is that mathematics, viewed through the lens of these desires, can in fact help us flourish. What happens when we see something beautiful, like that painting earlier, or like this figure, which a friend drew for my book? It's a figure that's standing before a mathematical pattern and reflecting, right? Beauty causes us to be quiet, to reflect, to observe, to notice, and to wonder. When we stand in awe of something beautiful, we search for its meaning. This is done by the mathematician Frank Ferris. We begin to ask questions like, why is this, what's going on in this picture? Why was it made? You see a striking pattern governed by mathematical laws, and it makes you ask why. And why takes us from sensory beauty, right? The beauty of fractal pattern in cauliflower, the beauty of turbulence under an airplane wing, or the beauty of patterns in sand. And it causes us to go to seek out wondrous beauty, which I like to think of as the beauty of ideas, right? The idea that you can add an infinite number of things together. That's an interesting, beautiful idea, right? And wondrous beauty actually brings us then to another level of beauty, which I like to call insightful beauty, the beauty of reasoning, right? This is maybe a unique form of beauty found in mathematics, that demonstrations of truths themselves can be awe-inspiring. Mathematicians even have a word for this. We say an idea or a proof is elegant, right? This picture here below is maybe one way to help us think about insightful beauty. If I take a square and I cut it up into 4 pieces and color 3 of those pieces, red, green, and blue, and then I take the remaining square and cut it into 4 pieces, red, green, and blue, and I keep doing that with successively smaller remaining squares, you see that the area of the red pieces is the sum of the areas powers of 1/4. There's red, green, and blue, and they all match up square for square. So they're all the same area. And so the total area of this square, if it's 1, means that the area of the red squares is got to be 1/3. And so in a striking visual way, we see the truth that the sum of the powers of 1/4 equals 1/3, just from looking at a picture, right? That's insightful beauty. That's a certain kind of beauty that makes you go, whoa, I see why that's true. It actually makes you ask more questions like, whoa, what other kinds of demonstrations can I show this way through a geometric argument? And that brings us to maybe the deepest form of mathematical beauty, which I like to call transcendent beauty. It's what happens when you see the same beautiful idea, object, or reasoning pop up in multiple places. It's almost like the universe is speaking to you, right? That kind of beauty can feel sublime, almost divine. And this transcendent beauty we find in the world provokes in us a feeling that there's something just beyond our grasp that may be of ultimate meaning, just waiting to be found. C.S. Lewis spoke of the sublime experiences of beauty as, quote, the scent of a flower we have not found, the echo of a tune we have not heard, news from a country we have never visited. And in a similar way, mathematics can feel transcendent, right? When you see the same idea pop up everywhere, you begin to think it is pointing to some deeper truth you haven't yet grasped. When you realize you've had exactly the same mathematical thoughts as another person, separated from you by oceans, culture, or time, you begin to believe there might be a universal, enduring reality that you're somehow both accessing, right? That's like whispers that are calling to us, but we haven't found their source. And when you pursue mathematics for its beauty, it cultivates in us certain virtues, like the virtue of reflection when you contemplate beautiful ideas, just like you'd contemplate a beautiful forest. It leads to joyful gratitude, transcendent awe, right? These are experiences when you do mathematics that you can have, virtuous experiences like these. And it brings us to, when you see profound beauty from seeing a beautiful idea everywhere, it builds in us another virtue, which I think is one of the most important virtues built by mathematics, and that's habits of generalization, because we begin to expect overarching patterns everywhere, right? So when I learn a new idea in math, I often ask, what gives this idea its power? What's the underlying principle? How might it apply in a more general situation? And such habits carry over to other areas of my life, right? When I'm cooking a stir fry and I learn a new recipe, I often ask, what general principles does this recipe teach me, right? Add garlic and chopped onions first, or put in basil at the end because it's going to lose its color, right? These are principles, right? Because you know what? I don't want to have to memorize recipes. I'd rather understand principles. And this habit of looking for general cooking principles or math principles allows you to improvise new delights. That's what allows us to innovate. So what can we do to encourage our appreciation of mathematical beauty? Well, one is to just look for beauty everywhere, right? Look for patterns in art, in music, in rhythm, in culture. Even something as boring as memorizing a times table, you can help your kids, if you're teaching kids to their times tables, you can ask them to look for patterns first. It'll make the memorization much more interesting, right? Elegant ideas, elegant reasoning. These are ways that we call out beauty. I have a website if you are looking for ideas. Ways that I've sprinkled mathematical beauty in my courses are 5-minute fun facts. And I've created a website where you can see a whole archive of a couple hundred different things that I think are beautiful. But cultivate your own examples if you're a teacher or if you're a parent. What's mathematically beautiful? Here's another basic human desire, the desire to explore. Exploration is a basic human desire. When I was a child, I loved the stars, and I grew up in a small rural town, far from any big city, in a place where you could actually see stars. I mean, right now in Los Angeles, I can't see any stars, hardly, at night. But in the small town where I lived, I could see the Milky Way. And so I begged my parents for a telescope, but we didn't have the money. So I just devoured books on astronomy, and I dreamed about space. And when I was a kid, I saw pictures like this for the first time in the newspaper, right? The Voyager probes were going through the rings of Saturn. You see, exploration is a deep human desire. It captivates our imagination. It's a mark of human flourishing. And I could explore these worlds even from 900 million miles away. And math exploration is very much like space exploration, isn't it? A different kind of space, though. It's a space of ideas. But it's similar in that you don't know what you'll find when you start. You send out probes, in some sense, to test theories. And just like beautiful art, you're captivated by mystery. You're motivated by questions. You're unfazed when you hit a setback. And you make discoveries from a distance, don't you? Because the ideas themselves aren't physical. You access the space through reason. And exploration is at the heart of what it means to do mathematics, isn't it? You don't need a lot of resources except your mind to be a math explorer, right? And as a result, you can embark on an adventure from anywhere, a prison, a small rural town, or some far-flung corner of the earth. Why can't our math classrooms be like this? Exploration cultivates in us virtues, doesn't it? Like imagination and creativity, right? In order to solve problems, you have to dream up new possibilities. And mathematical explorers like to dream up new ways of visualizing patterns. That's what makes that GPS possible that's sitting in your pocket. And they begin to envision the hidden structures that underlie the world that we see. I like to tell my students, math is the power to see the unseen, the hidden structures of the world. And that exploration cultivates in us an expectation of enchantment. This is another virtue I think is one of the most important virtues in mathematics. Explorers are excited by the thrill of finding the unexpected, especially things that are weird and wonderful, right? Isn't that why we go on hikes through unfamiliar terrain? Isn't that why we explore caves? Isn't that why we are fascinated by deep sea ocean creatures of the deep sea ocean floor? We're looking for things weird and wonderful. And in math, it's the same way. When you take a fractal Menger sponge with cubes cut out of it, like this picture, and you slice it diagonally, and you, what? Find a bunch of hexagonal stars? Huh? That's weird. That's wonderful. That's enchanting. It's surprising, isn't it? It makes you want to look at that thing and put the two pieces together and look at it again. Right? And we learn to expect enchantment around every corner. That's what makes math exciting to learn. Right? That's what keeps us coming back for more. And in a pandemic, it wouldn't surprise you then to learn that sales of puzzles have gone through the roof. Why is that? Well, it's because in a time of great distress, people are often looking for escape. And math offers an enchanting escape. Mathematical thinking is what puzzles are all about. One of the things that Christopher and I have done during the pandemic with several other mathematicians is we wrote a paper together, which is exploring a game that Chris and I first started playing in our correspondence. It had lots of interesting mathematical ideas. It just appeared in the Mathematical Monthly this past month. Enchantment. And so if you want to make math enchanting, if you are a parent and you're teaching your kids, or if you're just someone who has always found math very abstract, but still want to learn more, you can think about ways to view math through the lens of exploration. Often I like to change dull problems to exploratory problems. I like this figure from Math with Bad Drawings, Ben Orland's book. He talks about how, you know, when sometimes you ask kids to compute the area of a rectangle and you ask them to do 20 rectangles, you're just asking them to multiply two numbers and they never have to think about the meaning of an area. But if you change the problem to something like create two rectangles so that the first has a bigger perimeter and the second has a bigger area, that's a more exploratory problem, more interesting, and you grapple with the underlying notions. If you ask students to come up with a strategy for solving a problem, you know, sometimes people think of math as just computing or finding an answer. And actually, often it's more about coming up with a good strategy and then trying to see or make that strategy work. Which strategy is better? Open-ended questions are a great way to help us explore mathematics. And of course, you'll often encounter surprise or enchantment. You see, if you think about math as just memorizing things and not making sense of things, of course, you're going to think it's dull and boring. And what would it be like to think of math as exploration and open ourselves up to enchantment? For somebody like Christopher, math isn't just a tool, is it? It's hidden treasure. And at every step, we need to counter the idea that math is memorization and replace it with the idea that math is exploration. That's what allows a mathematical explorer to innovate. I praise good questions in my class rather than just good answers. I tell my students, I'm going to train you to be a mathematical explorer, to think, to reason, to solve problems you've never seen before. Here's another basic human desire, the desire to play. Now, what makes play, right? You can think of all the different kinds of play you engage in, you know, sports play, musical play, word play. What makes play play? Well, of course, it's got to be fun, but there's lots of other aspects of play, aren't there, right? There's often some kind of structure, like the rules of a game, but there's often freedom within that structure, right? So you're playing musical notes that have structure, but you decide what notes to play. That's freedom. There's investigation that often leads to some kind of surprise, right? There's often no great stake in the outcome. There's surprise and imagination, as I've mentioned. You use imagination when you play. You see, mathematics is play. It makes the mind its playground. And what does looking at math in this way do for us? Well, it builds in us hopefulness. You might think of this, think that's strange. What do you mean hopefulness, right? Each time you solve a problem, you work hard at solving a problem, and you eventually solve it, you are training yourself to be hopeful that you'll solve the next problem. And I wouldn't underestimate this virtue, because, you know, if you grow up in difficult circumstances and you have all your life never seen hard problems solved, being able to solve math problems and build in that hopefulness is part of what makes a mathematics education so powerful for people. It's why it's a great leveler, education is. Concentration is something you build up by viewing mathematics as play, right? When we play a game, we learn to concentrate on the play of the game. The same thing happens in mathematics. The ability to change perspectives. When you play, you look at what you're playing from your point of view and your opponent's, right? And isn't that what we do in mathematics often, is we change perspectives, right? We look at a problem algebraically and we look at it geometrically. And we say, oh, there's some connection between these two ways of thinking. You build in perseverance is another good example of a virtue that's built by mathematical play. And so play centers questions, investigation. It de-emphasizes the role of grades. I like to tell my students grades are a measure of progress, but they're not a measure of your mathematical promise. I am much more careful now to value process, not just outcome. For instance, I'll ask my students as a as part of my assessments, what have you learned in this class about the process of doing or creating mathematics? How can we make math a playful sport, not a performance sport? Here's another basic human desire, the desire for truth. And of course, we all know that truth is under attack these days, especially when we see, misinformation abound, either online or in political conversations. Fake news is routinely shared, right? Social media amplifies the outrageous. And so Pontius Pilate's exasperated question, what is truth, really hits home. I hear the same hopelessness when friends of mine say to me, it's too hard to figure out what's going on in the news, so why should I even bother? But you see, truth is a basic human desire, isn't it? It's a mark of human flourishing, and a flourishing society values truth, whereas societies that suppress truth have historically been oppressive. I like what Hannah Arendt said in another turbulent time, the late 60s. She's a political theorist who said the result of a consistent and total substitution of lies for factual truth is not that the lies will now be accepted as truth, but that the sense by which we take our bearings in the world is being destroyed. In other words, she's saying the danger here is not just that the lies are going to be accepted as truth, but that our sense by which we take our bearings is being destroyed. Why should I even bother, was my friend's question. And mathematical thinking actually helps us, equips us to figure out what's going on and to bother, doesn't it? Right? It builds in us this virtue of deep knowledge, thirst for deep knowledge and deep investigation. Right? Math explorers are on a quest for truth. We want to see how far the rabbit hole goes. We have a confidence that truth exists and is worth finding out. Right? So in math, even when we produce an answer for a question we're trying to solve, we don't just take the answer for granted. We ask, why is the answer reasonable? Where does it come from? How does it relate to things I already know? Are there other ways of understanding this idea? And so when I see multiple ways of understanding an idea, it gives me confidence that I see the truth. Or if two ways don't quite jibe, it makes me want to dig deeper because I know I've made an error somewhere. Of course, in the time that we've been living in, we've seen the importance of having the thirst to figure stuff out and figuring stuff out for yourself, right? The virtue here is, you don't need to trust an authority to figure stuff out for yourself. Our face mask effective, right? Or this discovery of gravity waves. How does this thing that I see in the news relate to something I already know, right? The fact that gravity bends light, right? Gravity waves. So we build in us ourselves a virtue of thinking for oneself, right? Thinking rigorously. We're also circumspect about what we know and what we don't know, right? These are virtues built by a proper mathematics training. And they should play a deeper role in our lives as well, right? What's at stake if we don't develop these virtues? At stake is our ability to make informed decisions, to be innovators, not just consumers, to critique the uses of math in the world, and to not be duped. These are all important parts of the other side of thinking about virtue, is to think about what's at stake if you don't develop these virtues. Here's another basic human desire that we all have, a desire for power. Now, of course, when I say that, many of you are thinking, what? Power often seems like a bad word, doesn't it? Right? Because powerful people are not universally admired. To understand why, we sort of have to untangle what we mean by power, right? When we say a thunderstorm is powerful, what do we mean by that? I like this distinction, which I first heard from Andy Crouch, a writer. Basically, the distinction between creative power, right? Creative power enables sense making. It multiplies power in the subject and object, right? The power, when I teach, I'm growing in my power to teach well, and my students are growing in their abilities in mathematics, right? Power is multiplicative in some sense. On the other hand, coercive power limits the abilities of others for creative power. When you exercise coercive power, you are actually limiting other people's abilities. And I'm talking here then of creative power. In what ways does math enable creative power, right? And so an example here is, if you think about what math does, math builds in us abilities to interpret, to define, to quantify, to abstract, to visualize, right? These are all virtues that are built by a proper education in mathematics. These are all things that were so important in the pandemic, in modeling what was going on in the pandemic, to imagine, to visualize, to the ability to view things in multiple ways, to generalize, to identify structure, right? So when you think about what it is that employers are looking for when they're hiring a math major, it's not the skills like factoring a quadratic or knowing how to take a derivative, is it? It's the virtues that they're looking for. Virtues are more important than skills. Here's another basic human desire for justice. This is a full quote by Simone Weil. Justice is to be ever ready to admit that another person is perhaps something completely different from what we read in him, right? Every being cries out silently to be read differently. This is a picture here of my favorite Chinese restaurant, which I go to because it serves authentic Chinese cuisine. And, it's one of these places that when you order an entree, they actually give you an appetizer and they give you a dessert as well. And it's a bargain, so I don't complain that the appetizers are not authentic. Often the appetizers like some crunchy noodles. The dessert is like Jell-O, something like that, right? But one day I actually went to this restaurant with a Chinese-speaking friend, and when the appetizer came, it wasn't crunchies, it was these delectable pickled cucumbers. And when the dessert came, it was red bean soup, which is something my mom used to make, right? How come I hadn't gotten this before? I began to see a pattern. When I came with non-Asian friends, I would get the crunchies and Jell-O. But when I came with Asian friends who spoke Chinese, I got the good stuff without even asking. And then I noticed that my Chinese friends were also given a completely different menu, a secret menu with more authentic dishes. I looked around the restaurant and behold a bizarre sight, right? People side by side in the same place having very different experiences. Non-Asians ordering from a standard menu and getting Jell-O, Asians ordering from a secret menu and enjoying red bean soup. And now, even when I know about this menu, I'm often told, you won't like the stuff on that menu. Now, why do they say that to me? It's because even though I'm of Chinese descent, they assume because I speak perfect English that I must not be interested in the authentic Chinese food. Okay, so why am I bringing this up? Well, it's because mathematical spaces in the home, in the classroom, can often be like this restaurant, right? Whom do we allow a peek at the secret mathematical menu? With whom do we share mathematical delights like puzzles or games or toys? Or whom do we shepherd towards doing more math? And whom do we discourage? What conscious or unconscious assumptions do we make? You see, justice means treating people fairly, and it's required for human flourishing. We flourish, we experience shalom or salam when we treat others justly, and when we ourselves are treated justly. Simone Weil realized that correcting injustice must involve changing how we view others. Do you believe Christopher is capable of mathematics? See, if you believe that math is for human flourishing, you'll see if you look around at the demographics of who does math or science, that it doesn't look like the demographics of the population at large, right? We've kept whole segments away from the flourishing available in mathematics, either by lack of access or explicit messages of disapproval, right? Oh, you'll never be a successful mathematician, right? What kind of messages are we sending people? Maybe without realizing it. How can you extend a welcome to those who feel excluded from math or who don't see themselves as mathematical people? You know, when I say everybody has potential in mathematics, people often push back. They're like, what? Like, I'm not sure I believe that. Why do we not believe that, right? Learning a language is hard, but every person does it after years of practice as a toddler, right? To seek justice in mathematics builds in us many virtues, among them a concern for the marginalized in mathematics, a willingness to challenge the status quo, because when we see how our experiences are different from our neighbors, we're going to want the secret menu for everyone. Here's another basic human desire, it's desire for community. And maybe this is most relevant note to finish on if we're talking about how mathematics unites. Community is one of the reasons why people who do mathematics, because we enjoy the process of sitting with another person trying to problem solve. You get to know somebody in a different way, don't you? Right? Chris and I know each other because we worked on these problems together. We know each other in a different way. I don't just see his resume. I don't just see what's on the exterior. And yet math communities often can be exclusive spaces, can't they? They're often focused on a certain kind of achievement, often a narrow one-dimensional kind. It looks different in different spaces, right? In elementary school, people often use speed as a measure of mathematical ability. And those of us who do math realize that speed actually isn't important in mathematics. At the professional mathematician level, people often use, do you teach at a research university or are you at a teaching college, right? As if one is more likely to be of a mathematician or better mathematician than another, or the number of papers you've published, right? Why do we focus on singular achievements like that? Why do we rank people according to singular abilities? See, mathematics actually, if you've been around the block enough, you know that, like, hey, you know, if I'm working on a math problem, people bring different strengths to mathematics problems. And it's not just things that one-dimensional things, right? We have to fight the one-dimensional view of math achievement. There's lots of ways to evidence growth in math. And I've talked about many of them, virtues like creativity, persistence, and problem solving, the ability to strategize, the ability to visualize, right? People have often different strengths, and that's why we work together in community. So we have to think about how we praise growth in virtues as growth in math, right? Not just praising speed, not just praising a singular ability. Math is more multidimensional, right? How do we elevate and see each other's humanity in all that we do? Doing math in this way builds in us virtues like hospitality, vulnerability, in confessing our own weaknesses in math, often as a way to welcome people in. It helps build in us the ability the disposition to affirm other people, right? This should be a big part of what it means to do math, and it's not. It gives us the ability to pay attention to people. You see, if there's one message I want to leave you with, it is that we should think about math as growing in virtues, not just skills. In fact, virtues may be more important than skills. We have to fight the one-dimensional view of math. There's so many ways you can evidence growth in math: curiosity, imagination, habits of generalization, disposition to beauty. These are all ways. So don't let anybody tell you that math is pure logic, cold and heartless, right? A bunch of rules to follow. Excuse me. Who would want to learn that? Right? Who would want to teach that? That's not mathematics, because you can't separate the true practice of mathematics from what it means to be human. And if you want to teach mathematics well, you want to learn mathematics well, you have to connect it to the things that people long for, right? The underlying motivations that drive all of us: desire for truth, for beauty, desire to play, desire for community. So here's a challenge I want to leave you with. Can you believe that you and everybody in your life can flourish in mathematics, right? Who are you going to read differently? How are you going to have imagination for the sacred responsibility of teaching? All of us are teachers, aren't we? Whether we do math for a living or not. If you're a parent, if you're an uncle or an aunt, or if you help somebody else, or even if you just talk to others about about mathematics in some way. We send signals to others about who does math, who doesn't do math. How do we have imagination for people? Now, 8 years after he wrote me that first letter from prison, Christopher is studying advanced analysis, topology, algebra now. He's actually, another prison inmate has made news recently, also named Christopher. He's not the one that actually you've heard about in the newspapers. This Christopher is different, and yet in many ways similar. Chris is now studying in a prison in a prison cell 2 to 4 hours a day, right? He doesn't have the same access to resources that all of us does, and yet he persists, doesn't he? Can you believe that you and everyone in your life can flourish in mathematics, right? This is a challenge for me too, because I've fallen short of this ideal. I've written off kids because I didn't have the imagination that I needed. Right? You might have a Christopher in your life, fallen in with drugs, the wrong crowd, who never seemed interested in math, maybe even seems lazy, right? If you knew what he was going through, you might read him differently as well. And this maybe brings us to the last human desire. It's also perhaps the greatest virtue, and that's the virtue of love, right? Because what I'm asking you to do in believing that everybody in your life can flourish in mathematics is I'm asking you to love. Love is at the heart of what it means to be a human being. It's at the heart of every good teaching experience. It's at the heart of every virtue and anything meaningful in our lives, right? And to love and be loved is the supreme mark of human flourishing. Every being cries out silently to be read differently, right? Every being cries out silently to be loved. See, Christopher in prison wasn't just looking for mathematical advice, was he? He was looking for connection. He was looking for somebody to reach out to him in his mathematical space to say, I see you, and I share the same passion for math that you do, and you belong here. And when I was in the depths of despair in graduate school and ready to give up, one professor reached out to me. He said, I would rather see you work with me than quit. So I stand before you to ask, who will you love and who will you read differently? You see, everybody's a math person, and your deepest human desires reveal your mathematical nature, and you only need to awaken it. And to love another human being is to see each person as worthy of the beauty and joy that come from understanding. Who are you going to read differently? Thank you very much for having me.
Il y a des questions? I certainly have one question. So how do you manage to have your students flourishing in classroom? Is it easy or?
Well, I mean, I just like everyone else as a math teacher, I'm always growing. I'm always changing my practice. But I will say about 10 years ago now, I started shifting a lot of my instruction to ways that elevate virtues more than just elevating skills. So for instance, instead of just, here's an example. So we often, as math teachers, just, our exams, our homeworks just look like solve a bunch of problems, right? But if I'm really serious about thinking about mathematics as encouraging a disposition to beauty, or encouraging creativity, or encouraging the ability to strategize, then what I communicate in my class is often you know, often our exams, our assessments that communicate our values. And my assessments weren't reflecting any of these other things. Yes, creativity is probably implicit in some of the questions I ask, but how do you call that out? So for instance, I now, over the last several years, have made more use of reflective questions, asking students to reflect on what they find beautiful, asking students to tell me ways in which they, when they strategize to solve a problem. Like, for instance, a question might be, think of one problem that you struggled to solve over the course of the semester and tell me how the struggle itself was valuable. I often get beautiful responses that help me think about my mathematical teaching in ways that I wouldn't otherwise have thought of. And I often find it helps me to get to know my students better. They also get a sense of what I value. And I think they also begin to see that math is often, more of a process than just a bunch of answers to questions on an exam. So that's just one example of ways that I try to communicate these things to my students in ways that gives them space to hopefully to flourish.
Are there other questions? I don't know if we have some on the chat.
I just have to call out because I see oh, maybe I shouldn't do this here publicly, but I see somebody that I know.
If you see some things on the chat, go. Okay.
No, I'm just going to say, I see somebody I very much admire when I was an undergraduate student at the University of Texas, and she's here in the chat. I mean, online. I won't call her out, but I'll just say hello. And yes, I didn't know her that well, but I always admired her because she was a model of flourishing.
Is there someone familiar with the chat? If there are things that...
Hi.
Okay, Roman.
I don't know if you can see me, or thank you so much for the presentation, or if you can hear me. Yeah, okay.
Yes.
I was I reflect a lot about math and teaching math with friends at school in undergrad. And play is definitely a key part of it, of like pushing you and wanting you to know more, and just like in a way that's actually effortless, because and that's what we seek for, is really effortless learning. Well, there's always some effort to put in when you're stuck, but like in a way that your drive is more important than the difficulty of the problem. And in play, there's often the fact that you play with others, and you don't necessarily just play by yourself. Like if you're a child and you have an imaginary game, like you would have that like in school with others, or just board games with others. And I had also a very inspiring prof, and she would do midterms with the first part as a group. Problems that you have to solve as a group, and then second part by yourself. And the first part would only count if it increases your grade. So it was like there was no penalties if you were working with a group who had just less knowledge than you or something. And I was wondering if that was something that you did in your classroom, like because it was an idea that we had, just making people really work in groups.
Yeah. So it's a great question, great observations. I mean, I've certainly moved more in the direction of allowing group work. For instance, in analysis, to level the playing field from people who had some experience in proofwriting before with people who haven't. On the first several assignments, I allow regrades. So students can resubmit their assignment and only improve their score. Over the pandemic, before the pandemic, in our department, we developed a collaboration guidelines, which I could share in the chat if I can find the link. But this is basically a way that help coaches students on what good collaboration looks like. So for instance, one of the things it says is collaboration isn't just division of labor, right? in a good collaboration, people push each other to deeper understanding. And so when the pandemic happened, guess what? We leaned on this even more because we said, hey, we don't want students on Zoom screens to just be isolated. So we elevated the role of group work and coached them in what good group work.
Oh,
Any more questions or
Thank you so
comments?
much.
Okay, so it's my pleasure, Francis, to thank you for really an inspiring talk, and I hope that the teaching will change on our side. So happy International Day of Mathematics to you. It's not the end of the day yet for you.
And to you all as well. Yeah, you can see the sunlight streaming into my window just over the hour.
Okay.
So thank you very much.
Thank you
Thank you very much.
Thank you.
And thanks to you, Christian.